got the equation y equals ab to the x. This is the form, the general form of an exponential. Okay? So I'll say, this is a general form of an exponential function. X is your exponent. Okay? It's a new kind of function. Now we want to solve y equals ab to the x if we have 2 points on the graph. Well, what can you do if you have 2 points on the graph? You can find the linear function, right? Okay, that one's easy. Okay, everybody I think is doing that well. If one of the points is the vertex and the other point is on the graph of a quadratic function, you could also find the equation of a quadratic function with, say, this vertex containing this point, right? Or a different one, this vertex containing this point. Now, for a general quadratic function, you need 3 points. If one of the points is known to be the vertex, then you only need to know which one that is, and one other point, okay? And we've done all that. Early in the semester, we did it with the flow from the cylinder. You got 3 equations. You put 3 points into the form y equals ax squared plus bx plus c. You get 3 simultaneous equations. You solve them for a, b, and c. Okay? For a linear function, it's easier. Now we have an exponential function. And it turns out this one's actually easier than the quadratic. Okay? So, okay, if these 2 points are in the graph, meaning these are 2 x, y points, x is 2 when y is 5, y is 19 when x is 10, okay? Then we could depict that on a graph. We don't have to, but we could depict it. One way or another, though, we're going to put this in for x and this for y, and we get this equation, don't we? I mean, if I plug in 5 for y and 2 for x, you're going to get 5 here, and you're going to get 2 here, and that's what I've got here. And I'll bet you can tell me what happens if you plug in 10 for x and 19 for y. You know, bet if I ask you to write that down, it would look just like this. 19 equals a times b to the 10th. Okay? Now, we can solve this equation in any of about 3 different ways. Okay. I could.
Hey, I'm in there. You want to come to me to my equation first? Because I can help you.
Okay, well, let's just do what I did. I was going to go over kind of what we could do. But, yeah, one thing we could do that I'm not doing just now, but I'll probably write it out in a minute, is I could divide this equation by this one or this one by this one. If I do that, a divides out, doesn't it? And that would leave me just an equation in b. So that's one way to eliminate a, and that's perfectly valid. It's probably the slickest way to do it. Now, a more general way, because you can't always do it by dividing one equation by the other, is we solve this equation for one of the variables. And a is easy to solve for, so I'm going to solve for a. It's very clear that if I solve this for a is going to be 5 divided by b squared, right? Very straightforward. A is 5 over b squared. Okay? I take that and I plug it in to the second equation. So there's an arrow going down to here, right? Meaning I replace a with 5 over b squared. And now I've got 19 equals 5 over b squared times b to the 10th. Only one variable. I've eliminated a. If I solve one equation for one of the variables and then plug that expression for that variable into the second equation, I've eliminated one of the variables. Okay? Not in the same way you did it with quadratic or linear functions. Okay? But equally effective. and more generally applicable. Okay, so I simplify this. What's b to the 10th divided by b squared? If you're an MCR, don't say. Somebody else tell me. B to the 8th. Okay? Now remember, there's some question about what are you supposed to know when you come in here. Well, there's some stuff that goes on here that I wrote down here that has fractional exponents and radicals, okay? Other than a square root or cube root. That would be an MCR 8 or 9, so I don't necessarily expect everybody came in with that, okay? But if you didn't have those or the equivalent, hopefully you're in the MCR class. I said MCR, MTE 8 and 9, okay? But that's something that I don't think is covered very well in high school algebra. So I don't expect necessarily everybody came in with what they're theoretically supposed to know anyway about this. But you are supposed to know the laws of exponents, and I've told you that from the beginning. Okay? So we'll see what law of exponents we use, but that simplifies then to 5 times b to the 8th. 19 equals 5 times b to the 8th. How do you solve that? Well, first b to the 8th would be 19/5, right? And then you could take the 1/8 power of both sides, which is the same as taking the 8th root of both sides, and you get b equals the square root of the 8th root of 19/5. Now what are you going to do if you have the number 8th root of 19/5? Can you figure that out in your head? Could you figure it out even if you got to write everything out? How are you going to figure that out? You're not going to. You're going to let the calculator, and that's perfectly appropriate. That's fine. Okay?
8th root.
Okay? You take the 1/8 power.
So if we have something like this, this final answer without actually finding the 8th root would be acceptable. Like we don't have to put.
No, yeah, but actually it's going to be simple if you take your calculator and find the 8th root of 19/5. We'll do that in a minute.
Yeah, you might need to show me how to use a calculator.
Yeah, well that's easy. You just raise into the 1/8 power.
Never done it.
And we'll do that. I mean, we're going to do that, okay?
Okay.
But what I'm showing you is the scheme.
That little part.
Here it is. You get a solution to this, and then you plug that into your expression for A, and you find the value of A, right? Okay? So what I want you to see is the flow of the solution. You got these 2 points. Each point gives you an equation. So you have these 2 equations. You easily solve for A and plug that in to get this equation, right? Then knowing the laws of exponents, you know how to do b to the 10th divided by b squared, and you get b to the 8th. And if you don't know the laws of exponents, you're remiss, but you should still take time and fix them, right? And you don't really know them until you use them, so we're going to be using this one. And that gives you b to the 8th is 19/5. You plug that into your calculator in a way we'll talk about. Plug that back in here and you get the value of A, and now you've got your function. Okay? And if you graph that function, it's going to have a graph that looks like this. Just looks like the 2 to the x function, except the points are different. Okay? So now the graph looks like has the same shape as y equals 2 to the x. But with a different scale. And we're going to talk about scaling that graph. And in fact, we're probably going to go ahead and do it with this example. Okay? So let's go ahead and write this out. Okay, so okay, we got the 2 equations. First equation tells us that A is 5 over B squared, right? Everybody understand that? You should, but if you don't, no, that's why we're doing videos. Okay. Good heavens. Okay. This video's gone on long enough. I'm going to just cut it and then we'll pick up right there.